Hello, financial professionals. Hey, Charlie Gipple here with CG Financial Group. We are going to move and fast forward today because you guys like these videos where I basically talk and fast forward just versus my normal slow talking Iowan. So here's what we're going to talk about. We're going to talk about Monte Carlo, and we're going to talk about a client that has $1 million who wants to retire today at age 65. And that person wants to know basically how much money they could take over their retirement years from that $1 million. So by the time they're, say, age 90 and pass away, we want to be aggressive with the lifespan. So by the time they're age 90, they still have money in their portfolio. In other words, they don't want to experience the number one concern that consumers have today that are retiring, and that is running out of money. That is running out of money, their number one concern, which is not good. We do not want our clients to run out of money. We actually want our clients to be very happy when they're 90 years old and still have money in their account, right? So here is Monte Carlo simulations. And then what happens when you add an annuity to the Monte Carlo? So in a nutshell, what Monte Carlo simulations do is they say, hey, you have $1 million, you want to retire today. If you took, say, $50,000 per year out in retirement, maybe that's inflation adjusted, right? So 50,000 increasing each year for inflation. How much confidence do we have that you're not going to run out of money? So here's what the Monte Carlo is going to do. It's going to say, okay, so the $1 million, it's allocated to say 70% stocks, 30% bonds. The system will then know how volatile over time that portfolio has been. Based off standard deviations, which is a measurement of volatility. It will also know what that portfolio has averaged over time, right? Not that history is going to repeat itself, but it oftentimes rhymes. So then what the Monte Carlo will do is it will take 5,000 random scenarios, 5,000 stochastic, for those of you that took statistics lessons in college, which I did, and I think I got like a freaking A+ in the statistics classes. But yes, 5,000 different simulations over that 25 years. And here's one simulation, right? It was a good stock market period. Maybe interest rates were good on the bond chunk. This is a beautiful simulation right here. This is a beautiful scenario here because the client did not run out of money, right? So that's one scenario. And then it'll run like 4,999 other scenarios. Ooh, that one was a bad one. Maybe the client experienced a lost decade like 2000, 2010, low interest rates, et cetera, et cetera, et cetera. So it'll do this behind the scenes like 5,000 different times, 5,000 different times. You have some bad ones there, a couple of bad ones there, a couple of good ones there, a couple of good ones there. And in the end, if the system says something like this, that, hey, 90% of the time you did not run out of money, 90% of our 5,000 lines are to the right of our age 90 here, then what does that mean? It means that the clients are oftentimes told that, hey, we have a 90% probability of success, a 90% probability that by you taking out $50,000 per year from your $1 million, that you will not run out of money over your life. And that's not the real percentages with $50,000. That's just an example I'm just pulling out of the air here. So that's what Monte Carlo does, is it takes stochastic random scenarios and it says, yeah, we have a 90% or an 80% or a 50% probability. Now you can solve the other way as well and say, hey, in order to be, say, 80% confident, how much can we take over those 25 years of retirement? Maybe that number is $55,000 or something like that. Now, financial professionals, here's what's cool is what happens if you were to shave off, say, I don't know, $300,000, $300K from this portfolio and put it into an annuity. And that annuity is going to guarantee you a certain amount of income forever, say, I don't know, $20,000 per year. What is that going to do to this overall number? You plug that into the Monte Carlo simulation and then ask the simulation, okay, with the prior portfolio, we know that to be 90% confident, it was $50,000 per year that the client can take. But now that we have a third of the portfolio that's not in stocks and bonds and instead is in an annuity that's going to pay a lot of income, now what is our income number at the 90% probability? And maybe it looks something like this, as in $60,000. Hence, you've increased the client's income by 20%. Folks, that's what Monte Carlo is. And that is what annuities, especially nowadays, they've never been better than they are today from a payout standpoint. That's why annuities can enhance these models when Well, not just the models, the client's portfolio when you use them.